In this video, we're going to be looking at complex operations and equations, but for this specific video, I'm going to be focusing on the introduction of an imaginary number. What is that? And the cycle of I. All right, so there will actually be multiple videos for this particular lesson. All right, so first of all, we're going to look at what is I? What is an imaginary number? All right, so basically, if you have a negative under a radical, then you would write the radical as an imaginary number. So you would rewrite this. So I is equivalent to the square root of -1. So I is not a variable. We sometimes treat it like a variable so that we can, combine like terms and do operations with complex numbers, but it actually has a numeric value, just like pi. Pi is 3.14, blah, blah, blah. E 2.7, blah, blah, blah. I is the square root of -1. All right, so if you have a negative under a radical, then you rewrite it by pulling out the I. So we're going to look at some examples of that here in a little bit. All right, so if that's the case, then what is I squared? All right, well, think about it. If you know that I is the square root of -1, right? And we square it, well, then what happens? Well, when you square a square root, that essentially cancels it out, right? Leaving you with just -1. So what you need to know is that I squared is equal to -1. This is a biggie, okay? Like huge. So make sure that you remember that, all right? Because every time that you see an I squared in a problem, you're going to replace it with -1. All right, so we want to simplify it as much as possible. And if we know something has a numeric value, then we go ahead and we take care of that. All right, so sometimes you're going to have expressions that include real and imaginary numbers. And if that happens, then you're going to be dealing with what's called a complex number. So a complex number is just an expression that includes real and imaginary numbers. So real numbers are the numbers that you're used to. 5 is a real number. -5 is a real number. All right. Pi is a real number. Um, Even if it's not rational, that's okay. It can be rational, it can be irrational. Those are all still real numbers. The square root of 7, that's a real number. Okay. The only time it's not a real number is if it's a negative that's under the radical, which would be rewritten to include an I. All right. If it has the I or can be rewritten with an I, then that's imaginary. All right. Now, standard form of complex numbers are written as A plus BI. So A and B are real numbers because you have like 5I. Well, the 5 is real. It's the I that's imaginary. Okay. So, but long story short, real in most cases comes before imaginary. So I'm going to kind of talk to you about that when we look at these examples, because I'm going to kind of give you that counter example of when it's not necessarily true. Okay. So for example one, we would rewrite that. So it would be -4 plus 5I, real before imaginary. For the second example, you have some like terms that can combine, but I don't really want to do this. 6I plus 5, don't do that, all right? Instead, if you're combining like terms, go ahead and look at the part that is real, right? That doesn't have anything imaginary, and go ahead and write that first. So then we have a 5, and then we have our 2 and 4I to make 6I. So real before imaginary. In the last example, notice that there's an I squared. Well, what did we say I squared was equivalent to? We said that I squared was equivalent to -1. So I need to deal with that first. So 2 times -1 is -2 minus 6I. Is it in standard form? Real before imaginary? Yes. All right, so this would be standard form. So make sure that your order is correct. Now, as we go, you're going to see something that's not in standard form. So I want to show you what that might look like. All right. Or it's actually standard form, but it's just the way that you rewrite it. So if I were to have, let me kind of do this. If I were to have something like this, let's see, 4 plus the square root of negative 27. Negative 27. This might not be a good example, but because it has a radical or whatever. But okay, so this would be 4 plus 3 square roots of 3, but because there's a negative under the radical, there would be a I. And the I kind of gets sandwiched in the middle. Okay, so that is kind of a decent example. All right, so the I gets kind of sandwiched in the middle. The square root of 27 is 3 square roots of 3, but the negative is an I. So that kind of gets meshed in the middle. What you don't want to do is we don't put the I after the radical because somebody may mess up and think that the I is legit under the radical when really it's not. Okay, so I might have jumped ahead of myself a little bit. So for right now, maybe kind of forget that you heard that. All right, so this is where that kind of comes into play, okay? So when we take the square root of negative numbers, you rewrite the radical as a -1 times whatever that number is. So if we had the square root of negative 25, we would have the square root of -1 times the square root of 25. Well, what is the square root of -1? It is I. And what is the square root of 25? 5. Well, I times 5 is 5I. All right. Now, I showed an awful lot of work there, right? Okay, on my own personal paper, I would never show all of that work. Eventually, you're going to realize that if there's a negative under the radical, it comes out and becomes a I, because that is the square root of a -1. And we would know that our answer would include the I. All right, but it may help you to do the steps. All right, so on my own paper, I'd say, okay, what's the square root of 49? 7. Well, because there's that negative, it's 7 with a I. Okay, so that's how I would personally do it on my paper. Now, the real reason is because the square root of -1 times the square root of 49 is I times 7, which is 7I. Okay, now for this third one, we have the square root of a -32. Well, 32 is not a perfect square, so we would have to break that down. So you would have the square root of a -1 and the square root of a +32. Well, the square root of -1 is I, but then we have, the square root of 32, which would break down as 2 and 16, 4 and 4. So we have an I that's not in the house, right? And we have a Mr. and Mrs. 4. So we have 4I, and we have a square root of 2. So 4I square roots of 2 would be our solution. Now, piggybacking off of what I kind of did a little prematurely, that I, notice it's not at the end. We don't say 4I, oops, I messed up already. We don't say 4 square roots of 2 and then go, oh yeah, there was a negative, I need to stick the I in. We don't put it there because somebody may do something like that where that radical is a little bit more extended, and then somebody may think that the I is under the radical when really it's not. Okay, so we don't do that. We would say 4I square root of 2 instead. Okay, so that's why this is written that way. All right, so that's our basics of what an I is. It's the square root of -1. And then I squared then would be equivalent to -1. And then we talked about standard form and how to deal with a negative just under a radical. All right, so now we need to talk about the cycle of I because it's not always that simple. All right, you don't always just have the square root of a negative number. You don't always have just I squared. You may have I to the 9th power. You may have I to the 754th power. Like you could have huge exponents. All right, so we need to talk about the cycle of I. Now, I'm not going to, go too far with the cycle because you're going to start noticing a pattern. All right, and the cycle is obviously on the screen, but I'm going to kind of break it down a little more for you. Okay, so I to the 0. Anything to the 0 power is 1. I to the 1st power. Well, anything to the 1st power is itself. So I squared, I told you how to memorize, right? -1. All right. So then what is I cubed? All right. Well, obviously you can see it right here. It's -I. Okay. But I'm going to kind of show you why it's -I. All right. So I cubed is really I times I times I, right? Well, I squared, we already know, is negative 1. So what is negative 1 times I? Negative I. So that's where negative I comes from. All right. So what if I had I to the 4th power then? We would have 4 i's, right? So, well, 2 i's make I squared. Well, I squared is negative 1. Negative 1 times negative 1 is 1. And you'll notice that we have a 1 right here. So what would happen then if I had an I to the 5th power? All right, well, we still have all of this, but then this I would come down. Well, what is 1 times I? I. Well, what if it was I to the 6th power? Well, then I would have another I squared, right? Which we know is negative 1. Which would be 1 times negative 1 is negative 1. So then you can see that power. So you could kind of keep going, but I want you to realize that what's happening is the cycle is essentially just repeating itself. So the cycle of I repeats every 4 times, okay? Every 4 times. It just keeps repeating. So there's a shortcut that will help you kind of consolidate those, that process a little bit. All right? Because it repeats every 4 times, if you divide something by 4, then you basically have quarters, right? If I had, a whole football game, I divide it into what? 4 quarters. If I have a dollar, I can divide a dollar and break it down into 4 quarters. Okay. If I have a pie, I can cut it into 4 quarters, right? And that makes a whole. Okay. So every 4 times there's this cycle and it just keeps repeating. So if you can kind of remember this first little part, the first cycle, and then remember this little trick with dividing by 4 that I'm fixing to show you, then you'll remember and be able to figure out what these higher exponents then are equivalent to. So the step is to divide by 4 because we have 4 quarters, 4 cycles, right? Or I'm sorry, 4 things per cycle. And then look at whatever is after the decimal and think money. All right, money, money, money. Think money. All right. Ask yourself how many quarters you would have and then refer back to this chart above. Okay. So, for example, if I had 9 for my exponent, I to the 9th power, well, 9 divided by 4 is 2.25. We don't really care about the 2 here because that just tells me that I've made 2 complete cycles. What we care about is where do I leave off, all right? And we leave off with 1 quarter. Well, how many quarters is that? 1. So that means that I to the 9 is equivalent to I to the 1st power, all right? And then anything to the 1st power is itself, so my answer is I. So I really don't pay attention to this as much because I know my properties of exponents, but it may help you to have this little chart so that you can kind of refer back to it. So another example, and these are not on your paper, all right, if you're using my notes packet, because I wanted to just give you some random problems just to kind of reiterate the rule or the shortcut, and then you could do your own practice. So for this first example, I would say 734 divided by 4. All right, so 734 divided by 4. I get 183.5. All right, well, think about money. That would be $183 and what? 50 cents. How many quarters is 50 cents? 2 quarters. So I to the 734 is equivalent to I squared. And what do we know that I squared is? Negative 1. So I to the 734 then is equivalent to negative 1. All right, so then we look at the next example. Well, 131 divided by 4. 131 divided by 4 is 32.75. All right, well, again, we don't care about the 32. That just tells me how many cycles, right? We care about this part. Well, how many quarters is in 75 cents? 3/4. That means that I to the 131 is equivalent to I cubed. Well, what is I cubed? It is negative I. So, the little jingle, it's not really a jingle, but, it's 1I negative 1. So 1I negative 1 negative I. 1I negative 1 negative I. 1I negative 1 negative I. All right, it's just a pattern. You have your positives, 1I, and then you have your negatives, negative 1, negative I. All right, so it's just a pattern. If you can remember that pattern, you'll be in good shape. All right, so then this last example here, I would have 936 divided by 4. So 936 divided by 4 is 234. All right, now don't get confused. Think about money. And 234 what? Dollars. So are there any quarters? No, there's no quarters. So then this would be I to the 936 then would be equivalent to I to the 0 power. And anything to the 0 power is 1. All right, so that's your introduction to imaginary numbers, complex numbers, standard form, and the cycle of I.